Hey everybody, Professor Carafit here in the Bio 1440 lab. You can see the beautiful lab behind me where you would be sitting right now if we were meeting in person. So today I am going to show you the enzyme lab that we're doing for this semester. This is going to be a lab where you would have been manipulating yeast. Yeast is an organism that contains the enzyme catalase. Yeast is a eukaryote, just like you, and we are going to hit it with hydrogen peroxide, which reacts with catalase, releasing oxygen gas as a byproduct. And there's more information that you can read about this online and with the pre-lab video. However, this is something that I think is really important, even though you're not going to do it hands-on. So I want to show you how we would collect data, and I want to show you how to start to interpret that data. So let's begin. All right, everybody. So got on my goggles, got on my gloves. Safety first. So the first thing I did is I pipetted out 2 milliliters of yeast using this pipette, and I put it in the test tube right here. Now I'm going to use a different pipette to pipette out 2 milliliters of peroxide. Now, like I said, this is a little difficult because I'm on my own. So I'm going to go ahead and set that down. I wouldn't normally do that. And I'm going to click Collect Data right here on the computer. So right now, this probe is reading atmospheric pressure in the room at 750 millimeters of mercury. That's the unit right here. Down here we have time. So what I'm going to do now is I'm going to squirt the peroxide in with the yeast, and as quickly as I can by myself here, put this stopper in place. Okay? So let's see what happens. Squirt it in, stick the stopper on. It's bubbling, and you can see that the pressure is greatly increasing on the screen. Whoa, and there went the stopper. It popped off, and we have a lot of foam, and if I feel the test tube, it's a little bit warmer to the touch than it was when I started. We have a reaction that's releasing energy here, and we can see our stopper popped, pressure came back down, and now it's back at room pressure again. So I'm going to hit stop, and I'm going to auto scale the data here so it fits in the screen. Now the next thing that I would do is I'm going to use the let me find it, the linear fit button here. And I'm going to, oops, I did that wrong, sorry. I'm going to first highlight this data after the stopper went on. I don't want to get the room rate. I'm going to get this section of data right here. I've highlighted right around 10 seconds worth of data. No, I'm sorry, 7 seconds worth of data. And I'm going to click this button, and I get a slope. That tells me a rate. The rate of gas increase was 23.87 millimeters of mercury. That's a measure of pressure per second. So every second, the pressure went up by about 23.87 millimeters of mercury while this reaction was running. So I would write that down in my data collection table. And then I would repeat this process 2 more times at least to get at least 3 replications. And then what I would do, that was room temperature. Then what I would do is I would chill some of these samples. I would take peroxide and I would take yeast in separate tubes, and I would cool them off and let them sit at cool temperatures at a specific temperature for about 5 minutes. Then I would mix them together and see if that affects the reaction rate. I might heat some up and test those at a different temperature to see if that affects the reaction rate. So we could test anywhere from between 0 degrees Celsius and about 60 degrees Celsius, which is the hottest recorded temperature at Death Valley. And by doing that, we can get an idea of how that affects enzyme reaction rates. And you should be able to postulate a hypothesis as to why temperature might affect reaction rates. Will cold temperatures be fast? Will cold temperatures be slow? Will hot temperatures be fast? Will there be a point where hot temperatures have an effect on the enzyme, and why? These are things to think about, and you want to tie your predictions in with what you've learned from your reading and from the lecture videos.